Alright, we are going to have a quick discussion on Chapter 8, but you are not going to have any assignments on Chapter 8. But I do think there is some terminology in here that you guys need to be familiar with. So, SQL joins. Relational join operations merges rows from two tables and returns rows with one of the following. A natural join, which has common values in common columns. Equality or inequality, meet a given join condition. An outer join, have common values in common columns or have no matching values. And an inner join, only rows that meet a given criterion are selected. Alright, and it talks more about joins in your book. There's a chart or a table on page 324 where it talks about cross joins and inner and outer joins. Alright, again, let's talk about join operations. The inner join is traditional join, which only rows that meet a given criteria are selected. The join criteria can be equality condition, which is also a natural join or an equal join, or an inequality condition, also called a theta join. An outer join returns not only the matching rows, but rows with unmatched attribute values for one table or for both tables, which means in an outer join you can have some null values returned. A cross join performs a relational product or a Cartesian product on the two tables. Alright, here's that table that's in your book that goes over your joins. It gives you examples of the joins and what they would do. The cross one there at the top will return the Cartesian product of table 1 and table 2. The second one there will return the Cartesian product again. Old style join will return only the rows that meet the join condition in the where clause, where C1 and C2 matches in both tables. The natural join there will return only the rows with matching values in the matching columns. And then the join with the using word will return only the rows with matching values again in the columns. Join on returns only the rows that meet the join condition indicated in the on clause, and that again is looking at C1 for both tables. The left outer will return rows with matching values and includes all rows from the left table, whether it's null or matches or not. So the left table, everything is returned, and then matching values is returned for the table on the right, or table 2. The right join returns rows with matching values and includes all rows from the right table, which means everything from table 2 is included, whether it's a match or not. The full join returns rows with matching values and includes all rows from both tables, even with unmatched values. So you may have some nulls pop up with the outer join. Alright, then it talks about subqueries and correlated queries. Subquery is a query inside another query. Subqueries can return one single value, one column and one row. A list of values, one column and multiple rows. A virtual table, which is multi-column, multi-row, or no value. Output of the outer query might result in an error or a null or empty set. Alright, it gives you examples in the book. Like I said, we're not going to do any assignments on this stuff. I just want you to be introduced to the concepts. But over on page 332 in your book, if you'll look at the examples of subqueries, queries and subqueries, and if you have questions, let me know. Okay. The where subquery uses inner select subquery on the right side of the where. Values generated by the subquery must be of a comparable data type. Alright, if the query returns more than a single value, the database management system will generate an error. Can be used in combination with joins. In and having subqueries, the in subquery is used to compare a single attribute to a list of values. And the having subquery, a clause restricts the output of a group by query by applying conditional criteria to the grouped rows. And again, there's examples of these in your book. Look over them, and if you have questions, let me know. Alright, a multi-row subquery, any and all. The all operator allows comparison of a single value with a list of values returned by the first subquery. Uses a comparison operator other than equals. The any operator allows comparison of a single value to a list of values and selects only the rows for which the value is greater than or less than any value in the list. From subqueries specifies the tables from which the data will be drawn, and it can use a select subquery within the from. Okay. And again, there's an example on page 339 in your book of how you set that up. Alright, an attribute list subquery. Select statement uses attributes list to indicate what columns to project in the resulting set. Alright, an inline subquery expression included in the attribute list that must return one value. Column alias cannot be used in attribute lists. Computation of alias is defined in the same attribute list. And it shows you an example of an attribute list subquery on page 339 there at the bottom. The best way you guys are going to learn to do queries, subqueries, any type of work in SQL is to create you a database and play with the queries. Looking at slides and listening to a lecture, you're not going to understand it. You're going to have to work with this stuff. Alright, a correlated subquery executes once for each row in the outer query. Inner query references a column of the outer subquery. Can be used with the exists special operator. And examples for a correlated subquery is on page 342 in your book. Alright, SQL functions. Functions always use a numerical date or string value. Value may be part of a command or may be an attribute located in a table. Function may appear somewhere in an SQL statement where a value or an attribute can be used. Alright, there's a big list of, or a big table with your functions. Your access and SQL server date-time functions are on page 346 in your book. Your Oracle functions are on page 347 in your book. Your MySQL functions are on page 348 in your book. And your numeric functions are on page 349 in your book. You have string functions on page 350 in your book, carrying over to page 351. You have lots and lots of functions. You have your conversion functions on page 352 and 353 in your book. You need to take some time and look over these charts and learn these, not memorize the functions, but kind of look over them and see what they do. Alright, we're not going to go into all that because, like I said, you are not going to be doing any assignments or even being tested on Chapter 8. It's just, I wanted you to be introduced to some of this material in case some of you were planning on going on in databases. You will at least have heard some of this terminology. Alright, relational set operators. SQL data manipulation commands are set-oriented. Set-oriented, they operate over entire sets of rows and columns at once. You have your union, your intersect, and except minus work properly when relations are union compatible. Union compatible is the number of attributes are the same and their corresponding data types are alike. So they have to have the same number of columns, and the data types for these columns have to match up. All right. A union combines rows from two or more queries without including duplicate rows. All right, syntax query for unions. You have union all, which produces a relation that retains duplicate rows. Can be used to unite more than two queries. You have intersect, which combines rows from two queries, returning only the rows that appear in both sets. And the syntax for that query is intersect. You have the except minus. Combines rows from two queries and returns only the rows that appear in the first set. Alright, syntax query except or query minus. Alright, again, all this stuff is in your book. Union starts on page 354 in your book. The union all is on 356. Your intersect is on 357. Your except and minus is on page 358. You guys need to look at this stuff in your book, look at the examples, and let me know if you have questions. Alright, then the next section talks about virtual tables. A virtual table is based on a select query. The base tables are tables on which the view is based. You do a create view statement, the data definition command that stores the subquery specification in the data dictionary. You have the create view and create view as select. Alright, why would you want to use these views? You can use the name of view anywhere a table name is expected in an SQL statement. Views are dynamically updated, that is, the view is recreated on demand each time it is invoked. Therefore, if there's any updates, it will show up in the view. Views provide a level of security in the database because it can restrict users from seeing only specified columns and rows. Views can also be used as the basis for reports. Okay. Updatable views is used to update attributes in any base tables used in the view. Alright, a batch update routine pools multiple transactions into a single batch to update a master table field in a single operation. For example, a batch update routine is commonly used to update a product's quantity on hand based on summary sales transactions. Alright, updatable view restrictions. Group by expressions or aggregate functions cannot be used. Set operators cannot be used. And joins or group operators cannot be used with updatable views. Alright, Oracle sequences. We are not going to go over Oracle sequences. Procedural SQL. I don't really think you guys understand some of this stuff well enough to even go through that. Triggers. I don't think we're going to go over triggers either. Stored procedures. I don't think we're going to go over any of this stuff. Okay. Mainly, I wanted you to know about joins. In this chapter, I want you to know about joins and the unions and understand that stuff. So really, you guys need to sit down and read through chapter 8. Let's see, up through your intersect stuff there on page 360. From pages 323 through 360, you guys need to look through this stuff, read through this stuff, and get a basic sense of how this stuff works. And if you have questions, let me know.